Hello students, welcome you all once again on behalf of Resonance. आज 29th second shift की पेपर देख रहे हैं अपन memory based questions. First question given in this paper, why oxygen shows anomalous behavior in 16th group? The options given are due to large size, high electronegativity, due to small size, small electronegativity, due to small size, high electronegativity, and absence of vacant d orbitals, and fourth option due to large size, high electronegativity and presence of vacant d orbitals. So, in the P block, the second period elements shows anomalous behavior with the rest of the remaining period elements because of small size and high electronegativity and due to absence of vacant d orbitals in the valence shell of second period elements. So, the oxygen is showing anomalous behavior because of this reason, that is small size, high electronegativity and absence of vacant d orbitals. Not only oxygen, fluorine also shows anomalous behavior and nitrogen also shows anomalous behavior from the remaining group elements. Now, the second question, which of the following act as strong reducing agent? This is from a block elements. The given options are cerium 4 plus, GD 3 plus, europium 2 plus, terbium 3 plus. In this, the strong reducing agent is europium 2 plus and cerium 4 plus is oxidizing agent, and europium 2 plus, even though it is having 4F7 configuration, it converts to +3 oxidation state and act as the strong reducing agent. These are the direct lines written in the NCERT. So, you have to read the NCERT lines, then only this type of questions you can answer. And the next question, this is from coordination compounds. Correct IUPAC name of K2MnO4 is potassium tetraoxidomanganate 6. Here in this Mn oxidation number is +6. So, the IUPAC name for this is potassium tetraoxidomanganate. So, this is the correct IUPAC name. Next, fourth question, on reaction of which of the following Nessler's reagent gave brown precipitate? इसमें आपको अमोनिया, SO2, Cl2 and CO2 gases are given. इन चारों में Nessler's reagent, that is K2HgI4 in alkaline medium, can react with ammonia and gives HgO, HgNH2I. This is called iodide of Milan's base and it is the brown precipitate. So, only ammonia can give this brown precipitate and remaining gases do not give the brown precipitate with Nessler's reagent. Next question, this is from periodic table. Here the statement 1, fluorine has highest electronegativity in its group. Yes, it is true, and among all the elements highest electronegativity is for fluorine. According to Pauling scale, its value is 4. And oxygen has least negative electron gain enthalpy in its group. Yes, in this you can observe electron gain enthalpies. For oxygen it is -141 kilojoule per mole, for sulfur -200, selenium -195, tellurium -190 and polonium -174 kilojoule per mole. So, among all these elements least is for oxygen. So, the first statement, fluorine has highest electronegativity in its group and oxygen has least electron gain enthalpy in its group. So, both the statements are correct. So, answer 1. Next, this is also from periodic table. Which of the following has highest ionization enthalpy? In the given elements nitrogen, carbon, silicon, aluminum, nitrogen and carbon are second period elements and aluminum and silicon are third period elements. Top to bottom ionization enthalpy decreases. So, you can eliminate third and fourth. And in second period, nitrogen and carbon, nitrogen has half filled configuration, that is 2s2 2p3 configuration for nitrogen, outer configuration of nitrogen. For carbon, it is 2s2 2p2. So, due to half filled configuration, it is more stable, that is why it requires more energy to remove the electron. So, nitrogen shows highest ionization enthalpy in the given options. So, you can see the ionization enthalpy values, that is for carbon it is 1086 and for nitrogen 1402, for aluminum it is 577 and for silicon it is 786 kilojoule per mole. Next, nickel 2 plus on reaction with X gives rosy red precipitate. Here what is X? Here options are given DMG, paranitrophenol, ferric chloride, none of these. In the three options, DMG means dimethyl glyoxamate, and with dimethyl glyoxamate it gives rosy red precipitate. So, it is with dimethyl glyoxamate, it is forming a complex which is rosy red precipitate. Next question, select correct option regarding zinc, cadmium and mercury. Zinc, cadmium and mercury are 12th group elements and these are not transition metals and these are only D block metals. And for these elements, there is no unpaired electrons available. So, metallic bond strength is weak. Since metallic bond strength is weak, these are the soft metals only but not hard metals. And since there is no unpaired electron, these are diamagnetic in nature, not paramagnetic. And high enthalpy of atomization, here enthalpy of atomization is less due to less metallic bond strength. And mercury shows variable valency, whereas zinc and cadmium does not. Yes, it is correct. So, the first three are incorrect and the fourth one only correct, because mercury can exist in +1 and +2 oxidation states. So, it shows two variable oxidation states, that is +1 and +2. So, only the fourth option is correct. Next, this is from atomic structure and here the series of spectrum are given and the region where the spectral lines series are observed. So, Lyman, Paschen, Balmer and Fund series. In this Lyman series lines are observed in UV region and Paschen series lines are observed in IR region, and Balmer series, in the Balmer series the first four lines you can observe in visible region, Fund series observed in IR region. So, the first option is only correct. Next, the oxidation state of iron in the complex formed in brown ring test is. Brown ring test is for NO नाइट्रोनियम आयन की टेस्ट है, इसमें कॉम्प्लेक्स फॉर्म्ड इज फेरस नाइट्रोसो सल्फेट, दिस इज कॉल्ड एज द ब्राउन रिंग. इसमें NO oxidation number, this ligand oxidation number is +1, it is the positive ligand, and H2O 0, and if you find the oxidation number you will get +1. So, what is the oxidation number of iron in the brown ring complex? +1. Next, how many of the following have zero dipole moment? If the molecule has symmetrical structure, then the net dipole moment will be 0 and that molecule is called non-polar molecule. And in the given option NH3 in NH3 there is nitrogen is more electronegative, and if you observe these bond moments, these are all in one direction. So, the net dipole moment will not be 0. Next, H2O, it is also having two lone pairs, and the net dipole moment for this also not equal to 0. And for HF, it is also HF, here this HF is having hydrogen and fluorine different electronegative elements, and for CO2 the net bond moments are opposite to one another. So, the net dipole moment is 0 for this. And for SO2 there is net dipole moment not equal to 0. And for BF3 it is trigonal planar shape, and the net dipole moment is 0. And for CH4 it has tetrahedral shape, and the net dipole moment is 0. So, for how many molecules the net dipole moment is 0? For BF3, for CH4 and CO2, net dipole moment is 0. So, how many molecules are having net dipole moment 0? That is 3, CO2, boron trifluoride and methane. Next, 50 ml of 0.5 molar oxalic acid is neutralized by 25 ml of NaOH. Then amount of NaOH in 50 ml of solution is dash grams. इसमें ऑक्सैलिक एसिड सोडियम हाइड्रोक्साइड रिएक्शन से सोडियम ऑक्सलेट और वाटर बनेगा. इसमें मिलीमोल्स ऑफ ऑक्सैलिक एसिड, here 0.5 molar 50 ml is given, so it is 25 millimoles, and sodium hydroxide 50 millimoles are given. Now millimoles of law of equivalence if you apply, millimoles of NaOH equal to molarity into 25, that equal to 50, and molarity is given as 2 molar. Now millimoles of NaOH in 50 ml equal to 2 into 50 100, और mass of NaOH आप calculate करेंगे, then it will be equal to 4 gram. So answer can be 4, because you have to give the answer mass of NaOH, that is in grams 4 grams. Next, this is from thermochemistry. Enthalpy of vaporization of carbon tetrachloride is 30.5 kilojoule per mole. Then heat required to vaporize 284 grams of carbon tetrachloride is. इसमें ये कार्बन टेट्राक्लोराइड लिक्विड से वेपर में कन्वर्ट हो रहा है, और एंथैल्पी ऑफ वेपराइजेशन 30.5 किलोजूल पर मोल है. दैट मीन्स ये 1 मोल के लिए, ये 1 मोल लिक्विड वेपर में कन्वर्ट होने के लिए इतनी एनर्जी चाहिए. अब हमको दिया है 284 ग्राम. सो अब मोल्स ऑफ CCl4 कितना, 284 बाय 154, इतने मोल्स के लिए कितना एनर्जी चाहिए ये हम कैलकुलेट कर रहे हैं. सो हीट ऑफ वेपराइजेशन कैलकुलेट करेंगे 284 बाय 154 इंटू 30.5, देन यू विल गेट 56.2 किलोजूल. नाउ इफ यू गिव द आंसर to nearest integer, it can be equal to 56. Next question, this is from kinetics. Radioactive decay of bromine 82 isotope has half-life of 36 hours. The fraction of remaining particles in 1 day is. So, इसमें data given है, anti-log value of 0.2006 is 1.587, log 2 value is 0.30. Now, lambda equal to ln2 by T half, that equal to ln2 by 36. It is decay constant equal to ln2 by half life, that equal to ln2 by 36. Now, lambda equal to 1 by T into ln n naught by n, that means n naught means initial number of atoms, n t means after time t number of atoms. Now, we have to find this fraction. Now, this is lambda value is ln2 by 36 and time is you have to find 1 day, that means 24 hours. So, 1 by 24 hours ln n naught by n. Now, ln n naught by n upon ln2 equal to 24 by 36, that equal to 2 by 3, and if you calculate this ln n naught by n to, if you convert this into log terms, log n naught by n equal to 2 by 3 into 0.30 and log n naught by n equal to 0.2 and n naught by n equal to 1.587 and n by n naught equal to 1 by 1.587, that equal to 0.63. It can be written as 63 into 10 power minus 2. So, answer can be 63, because we have to report the answer to nearest integer into 10 power minus 2 terms. Next, ये इलेक्ट्रोकेमिस्ट्री का क्वेश्चन है, फैराडेस लॉस के रिलेटेड. ड्यूरिंग इलेक्ट्रोलिसिस ऑफ AuCl4 माइनस, current is circulated for 10 minutes and given mass of cathode is 1.318 grams. Then amount of charge circulated during electrolysis is dash into 10 power minus 2 farad. We have to report the nearest integer. अब इसमें AuCl4 minus में Au3 plus is gaining 3 electrons and reducing to Au, and weight can be calculated from Faraday's first law, W equal to Z into I into T. It is electrochemical weight, and weight is given 1.318. Z can be calculated as atomic mass upon number of electrons into Faraday constant 96,500 into charge, that is I into T. Now, charge find करना है तो 1.318 into 3 into 96,500 by 197 coulombs, and charge equal to 1.318 into 3 into 96,500 by 197 into 96,500 से divide कर रहा है to convert into farad. So, that can be equal to 0.02 farad and it can be 2 into 10 power minus 2 farad. So, answer can be 2. Next question, it is from chemical equilibrium. In a closed container, equilibrium concentration of ammonia, nitrogen and hydrogen are given 1.5 into 10 power minus 2 molar, 2 into 10 power minus 2 molar and 3 into 10 power minus 2 molar respectively. Then equilibrium concentration, equilibrium constant for the formation of ammonia at 500 degrees Celsius is dash into 10 power 2. So, formation of ammonia can be written like this, N2 plus 3H2 gives to NH3. Here equilibrium concentrations already given, 2 into 10 power minus 2, 3 into 10 power minus 2, 1.5 into 10 power minus 2. Now, if you calculate Kc value, you will get Kc value as 4.16 into 10 power 2, and you have to report nearest integer, that can be equal to 4. Okay. Next, this is from chemical bonding, molecular orbital theory. Using 2s and 2p orbital intermixing, total number of anti-bonding molecular orbitals formed. So, कितने anti-bonding molecular orbitals बनेगा? ये px orbital and s orbital, ये दोनों intermixing से एक तो bonding molecular orbital, एक anti-bonding molecular orbital बनेगा. सो आपको पूछा है कितने एंटी बॉन्डिंग मॉलिक्यूलर ऑर्बिटल बनेगा, ये के एंटी बॉन्डिंग मॉलिक्यूलर ऑर्बिटल बनेगा। सो आंसर 1, इट इज बॉन्डिंग मॉलिक्यूलर ऑर्बिटल, इट इज एंटी बॉन्डिंग मॉलिक्यूलर ऑर्बिटल। ओके बच्चों, यह है आज सेकंड शिफ्ट की पेपर। इस पेपर तो ये मॉडरेट लेवल की पेपर कह सकते हैं, ये तो इतना इजी पेपर तो है नहीं, मॉडरेट लेवल की पेपर है। और ये पेपर में हम ज़्यादातर ये ऑब्जर्व कर सकते हैं, इनऑर्गेनिक पोर्शन से एनसीईआरटी से जो लाइंस है वही से डायरेक्ट क्वेश्चंस आपको मिल रहा है, वो इजी लेवल क्वेश्चंस ही है। और कोऑर्डिनेशन डी ब्लॉक से कंपलसरी क्वेश्चंस हर पेपर में अभी तक जो 4 पेपर हुआ है, ये 4 पेपर में ये डी ब्लॉक से कंपलसरी क्वेश्चंस मिल रहा है और कोऑर्डिनेशन से भी कंपलसरी क्वेश्चन आ रहा है। पी ब्लॉक में आप एनसीईआरटी के लाइंस जरूर पढ़ना है ताकि ये कंपाउंड्स ऑफ पी ब्लॉक पढ़े ना पढ़े, एटलीस्ट स्टार्टिंग इंट्रोडक्शन टू प्रिपरेशन ऑफ एंड प्रॉपर्टीज ऑफ एलिमेंट्स तक ये तो जरूर पढ़ना है, क्योंकि आपको जो भी क्वेश्चंस दे रहा है वो कंपलसरी एनसीईआरटी लाइन से उठा के दे रहा है। मेनली वो टेबल वैल्यूज को ऑब्जर्व कर लो, इंक्रीजिंग ऑर्डर्स, डिक्रीजिंग ऑर्डर्स, इसी से क्वेश्चंस मिल रहा है। ठीक है बच्चों, ऑल द बेस्ट एंड वी विल मीट अगेन इन द नेक्स्ट पेपर। थैंक यू।